Let us see the second aspect of the kinds of ocean currents. The oceanic currents are classified according to the force that makes them to flow. The various kinds of currents include the tidal currents, density currents, wind driven currents, the gyres, rip currents, and the cold surface currents. The tidal currents are caused by flooding of water flowing from one location to another location. Normally, the flow speed of these tidal currents is very small, especially less than 0.5 meters per second. Tidal currents flow closer to the coastal regions. The density currents are created due to the variation in the density of water. The more dense saline water normally starts flowing under the less dense water. This is called as density current. It is mainly driven by the differences in the densities between the two water masses. These flows are a few centimeters per second or even less. The wind driven currents are the strongest currents in the world. As the name implies, they are mainly driven by the winds. The wind can cause a surface flow of normally 2.5% of the wind speed, that is 10 meters per second wind speed may generate roughly around 25 centimeters per second of surface water flow. This is known as wind drift. A current can also change its courses somewhat in depth and speed over time. Gyres are yet another types of currents in the oceans. Gyres are circular, large scale ocean flow patterns. They result from wind forcing, buoyancy forcing, and the Coriolis acceleration. Since the Coriolis acceleration changes with latitude, gyre circulations are not symmetric and the flow on the western boundaries are very stronger than the other sides. Gyres flow in clockwise direction in the oceans of northern hemisphere and in counterclockwise direction, especially in the oceans of the southern hemisphere. This happens mainly because of the Coriolis effect creating surface ocean currents. Gyres are of various kinds as subtropical gyres, subpolar gyres, and recirculation gyres. Near the Earth's poles, gyres tend to flow in the opposite direction. Some of the ocean currents move quickly while others move very slowly. Subtropical gyres are found in all the world's oceans at mid latitudes. Subpolar gyres have the opposite circulation and are found poleward of the subtropical gyres. Recirculation gyres are flows associated with major ocean currents and consists of water that recirculates in a closed pattern around most of the ocean basins. Large scale recirculation gyres are associated with fast western boundary currents. Mesoscale recirculations are associated with meandering currents. Rip currents are currents seen closer to the beaches when the waves tends to carry water towards the coast. Changes in the bottom topography can cause water to be moved towards the beach without allowing the water to return to the deep sea. The flow of water going back towards the deeper sea then occurs quite suddenly in the form of a narrow current, and these are called as rip currents. The narrowness may specify less than 5 meters wide and the fastness may be up to 2 meters per second speed. Anybody bathing in this zone who are caught by a rip current will be rapidly carried away from the coast. They should not try to swim back towards the beach because the currents will be too strong. Rather, people should stay afloat until the flow of the current reduces or swim parallel to the beach into the calm water zones. Rip currents are very dangerous and can lead to drowning. The next type of currents are the cold surface currents, come from polar and temperate latitudes and they tend to flow towards the equator. Like warm surface currents, the cold surface currents are driven mainly by the atmospheric forces and are influenced by the Earth's rotation. The East Greenland current, Labrador current, Malvinas current and the Benguela current are important cold surface currents in the Atlantic Ocean.